Today we're going to take a look at relative extrema and critical numbers. This is a highly tested item on the AP exam, and what they ask you to do is to look at the behavior of the graph in terms of its first derivative and then later on its second derivative. So what I've done is just sketched a simple function here, and I want to describe the derivative of this green function, y equals f of x. So the first thing I'd like to point out is that let's identify a couple of key points. First of all, here you can see that at point A it has a horizontal tangent, so the slope of the tangent line is 0 right here. And then again at B it looks like it has another horizontal tangent, and then again at somewhere around C it has also another horizontal tangent line where the slopes are equal to 0. So let me identify these real quick. Slope equals 0 here. Well, to the left of this point A, you can see that the tangent lines would all be positive right here. So what happens is the slope becomes less and less positive, and then it hits 0, and then just to the right hand side the slopes are negative, and they stay negative all the way until we get to B, where it switches, and you can see just to the right of B the tangent lines start becoming positive again. So the slope, or the derivative, the first derivative, is positive. It continues the same way until it stays positive till it gets to C, and then after C it looks like it shifts back to negative again. So what can we say about this? Well, the first derivative tells us that if the first derivative is greater than 0 or positive, then the function itself is increasing. And when the first derivative is less than 0, we know that the function itself is decreasing. And when the first derivative is equal to 0, we call this a critical number, and the critical number could be a relative minimum or a relative maximum. So what happens here is point A looks like a relative max. So relative maximums occur when the first derivative changes from positive to negative. Changes from positive to negative. And this identifies a relative max. Okay? And then what happens at B? At B we maintain that we reach a relative minimum because the first derivative changes signs, and it changes from, in this case, from negative to positive. So that identifies that we have a relative minimum. So we're going to take a look at a couple of techniques to identify these points, and then we'll wrap it up from there. So let's take a look at a fairly simple problem here. I've graphed y equals 3x minus x to the third power, and of course you don't always have the benefit of making a graph. Usually they'll just ask you this question, and you'll have to come up to conclusions based on some techniques here. But you can see here that at -1 the slope here is equal to 0, and also the slope equals 0 again when it's +1, right? So we have a horizontal tangent line here, and just describing the derivative, we have a negative tangent lines all the way down here till we get down to this -1, and then we switch from negative to positive, and we remain positive all the way till we turn the corner here at +1, and then the derivative becomes negative. So you can see that this function is decreasing when its slope, or its first derivative, is negative in this area right here. Let's see here. So the function is decreasing all the way till we get to right here, and then it's decreasing again when its first derivative is negative over here, and then somewhere in the middle, or in the middle here, this function is increasing, and its first derivative is equal to a positive value. Okay, well, let's come up with a quick handy way to take a look at these using some techniques here. So first of all, let's take the first derivative of this, and the first derivative of this would just be 3 minus 3x squared. Well, what we notice here is that at our critical values, the critical values are where the first derivative is equal to 0. So the first thing you're going to do is set the derivative equal to 0. So if you set this equal to 0, you have 3 minus 3x squared equals 0. Solving, you could move the 3x squared over, divide by 3. Divide by 3, you get x squared equals 1. And take the square root of both sides. And you can see that this occurs at positive and negative 1. So one suggestion is to develop what they call a sign chart. So let's do that over here. So the sign chart is just going to be a way for us to analytically look at the derivative. So I clearly label which derivative I'm doing the sign chart on, and all I have to do is identify where the first derivative is equal to 0, and sometimes I put a little 0 up here to remind me. Okay, so now we have this line split up into 3 sections, right? We have a section over here, we have a section in the middle, and then the section to the right of positive 1. So what I'm going to do is just pick a friendly value over here, say negative 2, and I'm going to plug it into our derivative. So let's rewrite our derivative over here so we crystal clear what's going on. One thing I could do is factor out a 3. Not necessary, but is a little helpful. So if I choose, say, a negative 2, so when x equals a negative 2, what happens? 1 minus a negative 2 squared. So we have 1 minus a negative 2, and we're going to square that value. And all of it's being multiplied by 3. This would be 1 minus 4, so this value is negative. Negative number times positive 3 is still going to remain negative. So I'm going to put a negative right here. That negative tells me that the function itself is decreasing until you get to negative 1, and you can see that we've already identified that over here. Then the next interval is between a negative 1 and 1, and always a good choice is to pick 0. So if you put a 0 in, 1 minus 0 squared is positive 1. Multiply that by 3, it's still positive. So here we have an interval where everything is positive. When it's positive, that means that the function is increasing. Increasing. Okay. Let me rewrite sign chart there. Now, and then we go pick a number to the right of positive 1, say positive 2. 1 minus 2 squared is 1 minus 4, which is negative. And you can see that that's going to end up being negative all the way till you get to infinity. So this function continues to decrease continuously. So here we can say that if a function goes from negative or decreasing to positive, then we have a relative minimum. And at positive 1, we go from positive derivative to negative derivative, so we're going to end up having a relative maximum. Okay? Well, let's take a look at the derivative graph. I went ahead and graphed it over here, so let me pull it up a little closer. So we can see it on the same screen. There we go. So you can see here that where this derivative, where the function reaches a relative minimum, the derivative is a 0. And then over here, we have our relative maximum, so we have a critical value at 1, and you can see that the first derivative is equal to 0. So this is a nice introduction into the critical numbers and what the first derivative tells us about a graph. Okay, I'll come back in a minute with an example of a little harder problem.